Okay, good morning, everybody. I am excited to soon introduce Sander to start his presentation from Schletter. We are super excited to, well, we have officially announced it, but to have our first webinar and introducing Schletter into our product portfolio. It has been a long time coming and we could not be more excited. Definitely a great addition to our product portfolio. So yeah, just a quick admin thing. So I'll post a link in the chat section soon to our website where you can find later today, latest tomorrow morning, the recording of this webinar, as well as past recordings and presentations of any webinars we have done thus far. So please make sure to check that out. And then, yeah, I'll hand over to Sander. Thank you again for joining us.
Yeah, thank you very much, Zane. Likewise, we're also very excited to get started with IBC in Africa. Of course, we have a bit of a partnership in Europe as well, doing some large-scale projects together, I believe in Germany at the moment, on the, I think, 30 megawatt plus sort of scale. So good to get the ball rolling this side as well. So my name is Zander de Bruin. I'm the sales manager for Schletter for Africa. The subject that we'll be covering today is the product range that we have available via IBC. IBC, of course, a well-known brand in the South African market and African market for a number of years already. So let's have a look how we can take it further together. All right, so in terms of the partnership with IBC, I believe we will have good stock availability in 2 warehouses with IBC. Pricing should be highly competitive. There's both kits and systems available and individual components. We'll be adding additional products as we go along, as well as I'll cover in the presentation. We have quite a strong focus over the next year on training and customer events, which will also include practical trainings, both on rooftops, where you get the opportunity to physically assemble the products and actually fasten them to roof sheeting. We're also planning a couple on the ground mount sector. So I'm very excited about the training. I think the training is what's going to be key to taking the South African market to the next level and increasing skills and professionalism across it so that the customers end up getting long-term value. Okay, so first subject we'll be covering today is our rooftop mounting structures, primarily for pitched roof. We'll have a look a bit about modules and module clamping requirements. With IBC, we've got 2 profiles of module bearing rails, which will be the Pro 35, which is a 35 millimeter rail, as well as the Pro 70, which is a 70 millimeter high rail. I'll get into why we're doing it that way a bit later. We'll look at seam clamps quite extensively. I believe that, especially in terms of commercial and industrial installations, concealed fixed roofing is a major area of solar installations over the last 2 years. So we'll look at the requirements in terms of seam clamps. IBR would probably be the second largest pitched roof sector. So we'll have a look at how to fix to IBR and some considerations around that. We're not going to be covering flat roof today, but we will do maybe early in the new year a segment on flat roof mounting. I'll give a brief overview on that, and we'll have some considerations in terms of tile roofs, but we'll have a look at how much time we have to cover the rest. So another exciting thing, all of our systems that we are running through will be available as well in pre-packed kit-based systems, anywhere from 2, 3, 4, and 6 PV module mounting kits will be available. I think the nice thing about this is you get everything you need in one box with the rails included if it's a railed system. It's small enough that you can put it on the back of a bakkie or inside some estate vehicles or a small LDV to transport to site, so you don't need a big truck to do smaller installations, which actually saves quite a lot of costs and makes it easier to handle. So we'll have some more details on that in the coming weeks. But these are all boxed up and ready to go at this stage, so very exciting on that side. Another area that we are working together with on IBC is on smaller scale ground mounts at this stage. So we will have ground mount systems that do not require geotechnical investigations or are quite useful to use on rocky terrain or landfalls or so on. So these kits are available in 2V8, 2V12, and 2V18, which means basically 2 rows of 8 modules in portrait, or 16 modules, 24 modules, or 36 module systems. So we can have a look at that a little bit. But these are flying off the shelves at the moment, a very popular product. I think that it's easier to make the switch from a rooftop installer to a ground mount installer than what people realize at this stage. And South Africa has a lot of available land. So I think that this segment will continue to grow. Okay, but before we get into all of the details, just a little bit about who we are. So Schletter is a company that's headquarters is in Munich. We were founded in Bavaria in 1968. Globally, we have more than 800 employees. I think we're closer to 70 gigawatt peak worth of systems installed over the last 20 years now, which includes both rooftop and ground mount. Many of our systems are innovative, so we hold more than 105 global patents on our systems. We've got an extensive catalog as we operate on every continent to cover every type of rooftop. There's quite a lot of products required. IBC's offering is at least tailored for the South African market and requirements. But as a point of reference, we are the largest rooftop mounting structure company in Europe and a global manufacturer. So in terms of South Africa, we've been in South Africa for more than 12 years. We've got multiple manufacturing sites around the world and similar sized branches in Australia and South America to what we have here. Of course, Europe and America being the powerhouse of the market is driving us from that side. We've got, saying 19 employees here, but I think we're on about 21 employees locally. So there's a technical team to support and assist IBC to configure solutions and design solutions where it falls outside the standard. But also, if there are bigger projects that come up, we have a dedicated team of more than 200 people that works on the larger scale 1 megawatt plus ground mount sector. So we're also very, very capable to support in that market if opportunities do arise. So one of the things that makes us different on our rooftop segment is that we offer a standard warranty of 25 years on our products. And I think the market norm in South Africa is 10 years. A lot of people are asking us, why are we doing 25 years? Doesn't it make sense to maybe try and shave 2, 3, 4% off our price and offer a 10-year warranty like everybody else? But what we are seeing is that module manufacturers, at least the tier 1 or serious ones, are offering module warranties in excess of 25 years at the moment. There are several power purchase agreements or private consumption projects for the PV segment that have lifespans of 15 to 30 years. The roof sheeting that we're mounting to, if we look at especially concealed fixed roofing like Global Roofing's Clip Lock or Sofintra Saflock, also offer warranties of, in some cases, up to 40 years. And for the homeowner, even if their source of financing is a home loan, that can even be 20 to 25 years in terms of the financing. So for the rooftop market, there is actually quite a large expectation for the installation to have a long lifespan of up to 25 years or more. So for us, it doesn't make sense to offer a 10-year warranty in between a 20 to 40-year roof sheet warranty and a 20 to 30-year PV module warranty. The life cycle cost does not make sense in terms of the initial saving of shaving off a few percent. So our objective is that the customer's investment must be protected, whether it's a residential project or a utility scale project. We take it seriously in both cases. Anybody can issue a warranty, but the warranty should also be based on something substantial. We've been exclusively manufacturing mounting structures for the PV market for over 25 years. We use the highest quality materials that are available without over designing for the application. We have ISO quality management, environmental management. We subscribe to global business best practices to ensure that we have a clean supply chain, which does not include modern slavery or corruption. Our products are certified by global bodies such as MCS. A lot of our components carry European technical approvals and have been tested in the German Institute for Building Technology. We've gone through underwriters' laboratory certifications where required to make sure that buildings will be covered for insurance in the event of fire or product failures. We also have our own laboratory where we do extensive practical testing, and a third-party laboratory in Germany, which we send all of our new products to for independent verification before we are allowed to start manufacturing them. So it's one thing to issue a warranty, but our warranty is based on experience, quality manufacturing, using the right materials, and international certifications. Okay, so the manufacturing and the product design is the one side, but the project design is often where things go wrong. And there's quite a lot of risks in installing rooftop or ground mount solar systems and mounting structure that we have to take into account. One is the temperature. You can have a lot of thermal expansion contraction on metals. So we have to look at the individual sites that we're dealing with to ensure that the designs are correct for that. What type of surface we're mounting to, whether we're talking rafters or IBR sheeting or clip block sheeting or different soil types, is very important. Fire safety is quite a big thing. As modules are getting higher wattage and larger, some of the old mounting methods are no longer applicable for the biggest modules that are on the market. And exceeding the operating temperature of the modules for extended periods of time can actually be a fire risk. Therefore, a lot of the module manufacturers have put a new requirement in recently that a minimum ventilation gap of 100 millimeters is required. So more on that later. Corrosion is a major cause of failure in terms of solar mounting structures. So ensuring that the metals that are used are compatible with each other for the climatic zone is also very important. And then wind. I think if you look at the picture over here from a hangar site, I think it was an Air Force base in the UK where the entire roof has left the structure. So designing for the correct wind zones and for the building that you're mounting to is an important factor. I think in the last reports that I saw globally, about 30% of PV insurance claims are wind related. So quite a big cause of failure in terms of wind. Knowing the substructure is right is also part of the design. Often falls outside our scope, but it is an important part of the planning. And planning and design is probably one of the biggest risk factors in South Africa, just because it doesn't always happen. There is a lot of competition and very low margins, so it's about getting in and out of the site as quickly as possible, and then planning and design can often fall aside, and the problem will be dealt with a few years later. So I think if you take all of these risks into account, and we from our side have taken most of them into account, and can offer guidance and support where required, where it falls outside what we've taken into account, I think that you've got a very safe structure which your client will be happy with for a long time. Okay, so safety is one thing, and it's one of the pillars of our business. But you can't over-design every single project. So cost optimization is just as important. If that doesn't make sense economically, then nobody's going to go ahead with the project. So We want to balance structural safety, cost, as well as sustainability, because at the end of the day, if our industry becomes as dirty as coal or oil, then we, again, might as well go back to fossil fuels. So these are the three pillars of our business, and they are equally important. The customer must be safe, it must be at the right price, must also be sustainable in terms of not just how we manufacture, but to ensure that that installation lasts long enough to give the customer a good payback period, as well as the GHG payback period. All right, so feel free to pop some questions into the chat at any time, because we do have a lot of time to go through today. I don't mind to come back at any stage as well if you have a question that you think of later. Before we move on to the rooftop segment, I just want to talk briefly about the ground mounts, just to give you an idea what is available. As I said, we will have a full presentation on this at a later stage, as well as practicals in Joburg and Cape Town. So we will keep you up to date on that. There's two major types of foundations that we use in terms of our ground mount systems. The first, which is used primarily on projects over 200 kilowatt peak, is pile driving or rammed pile foundations, which is the cheapest way to do large scale installations and has a very fast production rate in terms of mounting structure installation. But the cost benefit does not usually realize for projects smaller than 200 kilowatt peak. So for smaller projects, concrete foundations tend to be used. The most common being the concrete strip foundation, which is a rectangular foundation. And the reason for that is you don't have to conduct geotechnical investigations. You don't have to come and dig down 2 meters deep and see what is down there and investigate if there's rock across the entire site. So the cost of the extra cost of the concrete is weighed against the cost of the geotechnical works and design works. So for smaller projects, it usually makes sense to go concrete foundations. So coming back to the PV Max, this one has what we call the strip foundations. We keep them in stock as kits. Installation is fast, they're cost effective, and we've designed them to cover 95% of the wind zones and conditions for South Africa and Sub-Saharan Africa. If you have one right on the beach, we might ask you to consider, or if you're trying to put it on the top of a building in central Cape Town, we might also have some questions. But for the rest, it covers the majority of use cases. All right, so this is an example just of the structure for a 2V8 system, which is 16 modules, one row of 8 modules there, one row of 8 modules there. You've got your purlins, which clamp to the modules. You've got one strut going across, and then you've got your 2 foundation posts and your concrete foundation here. So this foundation is about 500 deep, which can either be installed by casting concrete above ground using shutters, or by trenching using a TLB or similar, or even manual labor, and then casting concrete in there, placing the posts in and tying them in. So very, very simple. Very good feedback from the market on this system so far this year. All right. If you have any questions about this, I'm also welcome to come back to it later, but I'm going to move on to Rooftop now. All right. So the first thing that I like to consider in terms of Rooftop is we're protecting the module at the end of the day. So we're clamping down the module. We have what we call our ProLine module clamps that are designed to be compatible with all modern modules. It's designed to handle frame heights between 30 millimeter and 47 millimeters. I know that 15 years ago, there was a lot of 50 millimeter thick module frames. If they do come back at some stage, we will take it into account. But for the moment, this covers pretty much everything we're encountering on the South African market. All of the top module manufacturers have a similar requirement in terms of 50 by 10 clamping zone, which is covered in terms of the design. It has a very, very fine integrated grounding and bonding pin, which is designed to penetrate through the anodizing on the PV module frame so that you don't have to bond every module to each other. It also causes little enough damage that it does not void the module warranties, which is an important part of any project. One tool to fasten, we typically use a handheld electric drill with a Torx T40 bolt, which looks a little bit like an Allen key bolt. And they are self-locating, so, integrated parts, so you don't have to pre-assemble them. You can just find the spot you want to click into on the rail or purlin in between the modules and click it straight into the rail, which is nice and fast. No real nuts and bolts to tighten. Okay, so I think this slide came a bit early, but I'm going to move on to now more in-depth design of how we would calculate appropriate mounting for different modules. We've got software which is available, which we also run webinars and training on. So if you want to register for that, please let us know. Currently, we're still using Schletter Calculator 3 or SCalc 3. Hopefully in January, we will launch our new 3D app, which is called Creator. This one is still based on Google Maps. Creator will be fully web-based. So what this does is it will verify pretty much every step that I'm going to run through next in terms of selecting mounting structure. And I'll give you some examples a bit later. Okay, so I think, did I skip ahead slightly? Just bear with me for 1 second. Should be at a different part of the presentation. I'm just going to reshare the presentation quickly. Apologies. Apologies, it skipped ahead for some reason. Okay, so if we examine the components of the mounting structure, you get two major types of systems. The one is a full rail system where you've got the module bearing rails running underneath every single part of the module. And then railless systems have also become very popular over the last 15 years, where you are only supporting the module frame and the module clamp to attach the module to directly to the rooftop. So on a full rail system, you have these components. You've got your mounting brackets. In some cases, that includes the fixings such as screws or bolts to attach that. We have typically have unique systems for each different roof type. We've got an item called a cross connector, which is a fast way to attach a rail to a fixing. We call it cross because it changes the integrated rail on the part to 90 degrees. So if you don't use the cross connector, you can mount it directly on the part. If you use the cross connector, then you can attach a rail to it and a module clamp. So those are the major components: the bracket, the fixings, the cross connector. Then you've got the mounting rail and the module clamp, which fastens the PV module onto the rail. There's technically an in-between version of this called the short rail system, where we just cut rail lengths into smaller parts to only support the parts of modules that are required for that system. But I'll give an example of that a bit later. Okay, so terminology, that's also important. When we talk about portrait, it's portrait or vertical mounting. So that is relative to the slope of the roof in the case of rooftop mounting. So you can see here on this IBR rooftop that's draining, and the fluting is running from right to left. And the modules are also long side orientated to that. So I call that vertical or portrait mounting. On the right-hand side over here, you've got the modules in horizontal or landscape. So if I refer to something being 8H, then I mean 8 modules in landscape or 8 modules in horizontal. But also still the same clamping zones apply over there. And if I talk about short side or long side clamping, I'm talking about attaching module clamps to either the long side of the module or the short side of the module. Short side clamping was very popular when modules were much smaller. As we've gotten over 500 watt modules, short side clamping is not really used anymore as the modules tend to bend too much, but people still do refer to it occasionally. But it's an important part of the design to differentiate between the two. Okay, so then if we take that and we look at it an array, so here is 3H3 or 3 landscape by 3 modules. Sorry, it seems to have kicked me out again. Okay, so here we've got 3 modules in landscape, 3 modules in portrait. So if I refer to rows, then this would be the columns and these would be the rows. Okay, so taking that into account, these are probably the most common clamping methods that we see for attaching PV modules to mounting structure. Short side clamping, as I said, is typically not allowed for large modules, especially for short rail methods. That was quite popular, but it was also used quite a lot in roof hook mounting on tile roofs where there was limited space. But due to the flex of the module in the middle, it's not very much allowed. For bifacials, that has in some cases been replaced by edge support clamping, where you run the rails to support the module frame, and then you still clamping approximately at 1/4 point of the module. So the most popular mounting method is 1/4 point long side clamping. This for larger modules we see mostly. There's a variation to that as well, which is called triple clamping. So especially in high wind zones, the modules need to be supported in the middle so that additional clamp basically just comes in the middle, and it's often used in corner or edge zones of roof, which I'll explain a bit later. Combination clamping you see more often on ground mounts. It is possible on some modules in some conditions. But what's good about it is that you can often share a center rail to reduce the amount of aluminium that you need to mount. But it's not frequently used due to not being preferred by PV module manufacturers. Railless or short rail tends to follow 1/4 point clamping or triple clamping with the center support depending on the wind zone. And the edge support it's not very much favored just because you're using a lot of aluminium rail to run lengthwise on the module, where on portrait you're using much less meters of rail, so that gets more expensive. But it is still used, especially on bifacials, because you also don't have a shading effect created by the module, by the rail running underneath the module. Okay, so the most typical clamping zones that I see on modules currently is, if you look at the total length of the module, it tends to be from 450 millimeters to 550 millimeters from the edge. So these figures are quite important as an installer to plan out where to place your mounting structure or where to run your rails underneath. They do at least give some tolerance in terms of 100 millimeters across there, that you can have some variability on the roof. In higher wind zones, this does the tolerance also does decrease, or you have to run a third rail across. So we talk a lot about winds and wind loadings. This is from the South African National Standard 10160-3, which is used for designing rooftops or buildings or any structure really that is going to be exposed to wind. They are busy updating. I think a new version did come out last year, but it's very much the same. Some areas are slightly different. And if you look, for example, up north, the wind speeds, the basic wind speeds much lower than down in the Cape, where you've got some red areas around Paarl and so on, which are very high wind zones. So this is what we call the basic wind speed, based on the maximum 125 or 150 years wind loads for the area. But these are then further affected by things such as the terrain category. You know, in the city, you've got a lot more obstacles that act as windbreaks compared to on open farmland or if you're next to the coast. So I'll speak about that a bit. The height of the structure is also a major multiplier in terms of the forces that the roof and the PV modules are exposed to. Where that module is located, so if you place it right on the ridge or the edge or corner of a rooftop, it's got more forces than if it's in the center. Same thing for an open area array, because the outside modules also act as windbreaks for the inside modules. And the tilt angle of the module also does affect its loadings. So a flat module has less wind loadings than one that is tilted up to 10, 15, or 20 degrees. Okay, so that's the first step in terms of wind loadings. The second step is what type of area are we dealing with? So if you look at the picture on the right here, you've got quite a lot of obstacles around, but it is also next to a lake or the ocean. So I've put an indicator here just to say category A is basically your worst, which is next to the ocean or next to a lake or totally open land that has no windbreaks or vegetation. Category B, B and C, I would say, are probably the most commonly encountered terrain categories. B is usually farmland because there are some obstacles. There's usually trees or some sort of vegetation or building that does create a bit of a windbreak. Category C is most urban installations because category D is basically just a city center where most of the buildings are over 15 meters in height, which is 5 stories or more. And then even in that case, you still need to take into account the height of your installation relative to the height of the neighboring buildings. So I'd say most of the time, if you're dealing with a farmland, it's going to be category B. If you're dealing with a town or industrial installation, you're going to use category C. But as an indicator, if we look at a typical site in Cape Town, in an urban setting, would have 0.49 kilonewton force on those modules per square meter. But if that was on an open site or next to the ocean, it's basically doubled the forces that it's exposed to. So the terrain category does make a big difference in terms of mounting structure design. So the reason why we're worried about that is, like I said, to protect the module that you're using. So if you're looking at your PV module installation guide, you will see that the different models and types, such as 72 or 54 cell modules, will have different requirements in terms of what they are exposed to or what you're allowed to expose them to. So when we're talking mounting structure, we're typically talking clamps mounting, not bolts mounting. There are some cases we can do bolts mounting. For example, tracking systems tend to use bolt mounting, but rooftop and smaller ground mounts are almost always clamp mounting. So if we can start from the right here, So corners of the short side, all of your 72 cell or bifacials are not allowed for that. Also, that's on the corners. This is further inside on the short side, not allowed. But your 54 cell, you do have some options on that. For the typical across the long side mounting that I discussed earlier, you'll find that the higher wattage modules give you maybe 100 millimeter clamping zone. So that's from 500 to 600, where some of the lower wattage modules will be 450 to 550. So this tends to be most of the modules that we see between, let's call it 550 and 620 watt currently tends to fall into this category. So it's usually one of these two. Okay, so what does this figure mean? That is the amount of force that that module was exposed to complete its certification and be allowed to be sold. So the one thing they don't make very apparent of here is that a factor of safety still needs to be applied to that. So when we apply a factor of safety to those figures, it means that that module is allowed to have a maximum of 1,600 Pascal force in terms of uplift from wind on it. Or if you don't design for that, the module warranty will not apply. And then if there's a problem down the line, they won't accept your claim, most likely. Miracles do happen, but it's unlikely. All right, so that's why we have design software. That's why we have kit systems that have taken into account most of the use case scenarios so that all of this engineering work does not need to happen every single time a module is installed. So we tend to look at what the force per square meter is that the module is exposed to and then offer solutions above and below certain values. Okay, so the roof shape also does affect what forces we're talking about. I'll give you an example now just from a gable roof. Industrial roofs tend to be monoslope. It's just slightly different edge and corner zones. And flat roof systems as well. I want to do an entire webinar just on that in terms of different ballasting methods and east-west systems and so on, and have a look at what's possible there. Okay, so it's deciding what is edge and corner on a rooftop is usually based on what is the dimension of the roof and how high is the building. So the higher the building gets, the bigger the edge and corner areas get. And those are high force areas that are usually avoided in mounting. So if we look at an example of a single story tile roof in Cape Town, the roof is 10 meters by 6.5 meters. So the center zone over here, we've got relatively low forces, no triple clamping required. So the blue squares here are our PV modules, and the lines are the mounting rails. These lines going vertically up here is the roof rafters that we're going to fix roof hooks to in this case. And the red dots are the fixings where the roof hooks will be going. So the center zone, all good. But if I move it into the yellow zone, it's almost double the load, and the red zone is more than double the load. So on a single story house in this scenario with this roof size, that's about 800 millimeters from the edge and about 900 millimeters from the edge there. And from the roof ridge, also about 900 millimeters. So it can, if you don't design sufficiently, it can limit the amount of space that you have on the rooftop to mount to. Then if we move that to a double story roof, then suddenly the areas get much bigger, even for the same roof size. And now these modules down here have gotten their edges into the higher load zones. So it would be recommended to add some additional fixings to support those modules. Okay, so that's the first factor to consider in terms of being compliant with the module that you choose as requirements, is what forces it's exposed to. So as I said, we've got software for big CNI installations. We also do a free design service that IBC can also assist you with. So when in doubt, ask questions. When in doubt, add a bit of extra mounting structure in the edges and corner. All right, so the next topic is the ventilation gap from the roof to the module. On lower wattage modules, that tends to be about 50 millimeters the requirement. So it's usually from the pan of the roof sheeting or the tile to the frame of the module. So we take this into account in terms of what rails we use, what mounting brackets, what roof sheeting, to ensure that there's a big enough ventilation gap. And that's more important than it sounds, because the fire safety is the one factor, but the module efficiency is also much better at low temperatures. So we do have quite a hot climate here, and a higher ventilation gap means a cooler module, which tends to mean more efficiency on the module. Okay. A lot of module manufacturers also have a requirement in terms of avoiding soiling. So either you need to clean the modules regularly, or you need to add a tilt to the modules for more than 10 degrees. That's, I think, in the majority of guidelines. So that 10 degrees means relative to the flat surface. So if your rooftop's already at 5 degrees, then you can tilt it an additional 5 degrees to get to 10. Not really something to worry about in the residential sector, as most tile roofs have a pitch between 20 and 30 degrees anyway. But a lot of large industrial rooftops have pitches from 3 degrees upwards. So the soiling needs to be addressed either via cleaning or by a tilt. So we do have tilt structures in the form of the fixed Z elevation profiles or A-frames that can be added onto any of our systems to increase that tilt as well. So if you'd have a requirement for that, let us assist to support you there. All right, I'll share a link at the end for the configurator as well, if anybody's interested in learning about how to use the software to calculate all of these items that I've run through now, then please let me know. Okay, so moving on to specific rooftop systems. So our biggest seller for the year so far has been on standing seam rooftop systems for large industrial projects. Most people know the system, well, know the roofing as clip lock, but there's actually quite a few variants to it. Global Roofing makes clip lock 700 and 406. Sofintra makes SafLock 700 and 410, and Youngman makes Diamond Deck 700. So these are roof types that have specific requirements because they're long warranty rooftops that you are not allowed to drill into. So we've got systems that match the requirements and are available both in portrait and landscape, which I'll give you an example of now. Okay, so most popular is our Seam Clamp 551/4. The reason why this product is so popular is it can be used both in landscape railless or in portrait railed. It is also one clamp that is suitable for all of those roof types that I mentioned, for clip lock, SafLock, and Diamond Deck. So if you didn't measure each part of the roof exactly in terms of its crests and widths and that, the same clamp will still work on it, which is, I think, a major source of frustration for installers sometimes when they think a roof is clip lock, but they get to site and it's actually Diamond Deck 700 and they have to go and buy another clamp from their mounting structure supplier. So the one size fits all on these profiles is great. It's also an integrated part that just uses one bolt to fix. So very fast to install, and it's got a mini rail on top, so the module clamp can click directly into that, and you can put a module in landscape on that. So as I said, this is an approved mounting method by all of the major roofing manufacturers. Here are the approvals from Global Roofing, Sofintra, and Youngman, but there are some important requirements in terms of how these systems are designed to take into account. Firstly, you're not allowed to drill into the roof sheeting at any time. You're not allowed to mount clamps within 75 to 100 millimeters away from the purlin that supports the roof sheeting underneath. I'll show you a bit more on that now. You're not allowed to clamp where the roof sheeting overlaps each other. There should be more than 100 millimeters in between the roof sheeting and the PV module. That's also a fire safety requirement from the roof sheeting manufacturer side, not just from the module side. And cabling should be in cable trays, not lying on the roof sheeting surface, or it should be using cable management. And when in doubt, it's recommended that the installer engages with the holder and issuer of the roof sheeting warranty and take pictures before and after the installation just to make sure no questions come up down the line. Okay, so I'll come back to that one. Something strange happening in terms of my presentation. Let me find the right slide now. Okay, bear with me. Okay. Okay, so this is what those roof types look like. I do have 3 different roof sheeting diagrams on here. So you see why it's so difficult to tell them apart. This is the diamond deck. It's slightly wider across there than the Global Roofing's clip lock. And that's why it's important to have one clamp that is suitable for them. So basically the way concealed fixed roofing works is you've got the steel structure of the building with the purlins running underneath here. Then they have these clips which are drilled into the purlin, and that holds the roof sheeting down, and then the next section sort of clips onto that section. So each section of roofing is about 700 millimeters wide, and it is important to note that it's about 233 millimeters from seam to seam. So that usage guideline means where you've got an overlap here, you're not allowed to put mounting structure on that. You can only attach to these center ribs, like this one or this one, there or there, there or there. So in this case, you would mount 100 millimeters away from the purlin, seam clamp attached over there. Okay, hopefully my picture comes up now. Just to add to the confusion, they also made a version which only has one mountable roof seam and then 2 overlaps. So that is something to take into account, and that is called the 410 clip lock or SAF lock. Okay, so what that looks like, basically, you place your seam clamp onto that mountable seam of the roof. One tool required, drill using your Torx T40, just like the module clamps, to fasten that to the roof sheet. If you're doing a rail system, cross connector comes on, place the rail onto the cross connector, fasten again with Torx T40. So one part required to fasten the module clamp, same part for the cross connector, or same tool for the seam clamp. So looking at that on a larger scale installation, fasten the seam clamp. Over here, I've just taken a picture of a jig that they've used to ensure that the clamps are spaced within those clamping zones that we discussed earlier. So they've just taken a piece of pipe and made marks on it to say, okay, that is, 1.45 meters as per their module that they're using. And then they place the rails across and fasten. And once that's done, then they can place modules, and you can see they've clicked in the module clamps along the line where the rail was there. Okay, so if we look at it from a structure perspective, a typical use case, so the red dots being our fixings, we've now got a 1.4 meter span in between each fixing. If you If you count out, you'll see it's about 700 millimeters typically from mountable seam to mountable seam. So 1.4 meters is just double that. So we're taking every second mountable seam to attach a clamp to. So if we take that over 16 modules in a ported rail system, it's 28 seam clamps going across, 28 cross connectors to attach the rails to. You've got 8 rails, 4 on each side. The rails have a slide in splice, which I'll show you next time my presentation crashes, how easily that connects different rails. And then the end caps basically seal off the end of each rail, and the module clamps being 4 end clamps at the start. So that's 1, 2, and 2 at the end. So 3, 4. And then in between each module, you need the middle clamp to hold the modules down. So we've got 30 of those. So that also covers the majority of clip block roof sites. When it's close to the ocean, when it's an especially high rooftop, it might be good to add some additional clamps. In general, it's good to avoid the edge and corner zones, which is also easier on large industrial rooftops because you're talking in, a meter and a half from the edge, but you've got hundreds of square meters to work on. On a residential roof, it's more difficult to avoid edge and corner zones. Okay, so there are also other concealed fixed roofing out there. We actually do have seam clamps that work in exactly the same way for the others, being Brown-Built or Diamond Deck 407, Craft Lock, Calzip, Fisher Clip Tech. I think Ryan Zink has a couple of titanium roof sheets that are different that we also have those for, but we don't typically keep these ones in stock because the majority of rooftops are done with those 3 roof types or 4 roof types that I've now mentioned. If you do have a project that will require one of these, then just let us know. IBC might not have it in stock, but they can get it rather rapidly. So if we planned it in advance, there won't be a problem to supply. Okay, so moving on from concealed fixed roofing or clip block roofing, the next most popular system is on IBR systems. There's also many manufacturers for IBR, but their requirements are not as tough as the seam clamps. The major ones is Tough Deck 686, Wide Deck, or IBR 686. So most people are familiar with this, but basically it is a trapezoidal shape with a pan that repeats throughout. And typically they are, if we look at Global Roofing Solutions IBR, the spans there are 171.5. If we look at Sofintra Tough Deck, the spans is 171. The height is 36 versus 35, so it's almost identical. So from a design perspective, we treat them to be the same. There are some that have wider spans than this, such as the Wide Deck, but our products are designed to take that into account, that it doesn't matter. Okay, so let's have a look at a ported railed system called Single Fix. So Single Fix is a small rubber gasket with a steel plate that a rail can attach to, and it has 2 fixing points for screws to drill into the IBR. You can't see it too nicely on this picture, but you can see there's a fixing point there under the rail. There will be one there or there, and likewise all the way down there. So this span over here will be predetermined by our software, or by us, or by the kit system that you're using, and then that will just be repeating throughout. So IBR is pretty straightforward compared to the concealed fix. And then you'll notice that we're using quite thick rails here compared to our other systems. This is for that ventilation gap that we were talking about earlier, so that the modules have high clearance over the rooftop. It has a second added benefit that high rails are also strong rails, so you can span it pretty far in many scenarios using less screws and fixings, which also saves you time on site. So if we look at how we mount that, the major component being the rail, and then the single fix has this little flange over here, which twists into that rail. So basically you place the rail on top of the roof sheeting, and then you don't pre-drill these into the roof. You place the rail down and you come and twist them in, and then they sit nicely on the side there. And then when you're ready, then you can come and fasten them. So maybe at the end I can find a piece lying around here just to demonstrate that, but it's relatively straightforward. In terms of how you fasten it, we prefer that you have the screws countering each other down the line. So it's better not to have one there, one there, one there, one there. You get a better resistance on the rail if you've got one screw facing that way and one screw facing that way. So the components on this system is our Pro 70 millimeter high rail, the Single Fix Pro, which is a EPDM gasket that's also designed to last more than 25 years, and our European technical approved thin sheet metal screws, which is the vital part of the system because that is your connection between the thin roof sheeting and the strong mounting structure. So we take the screws quite seriously. I know that there's a lot of screws on the market in South Africa that people use for mounting structure, such as stitching screws or Tex screws or so on. But we use the high-grade screws because we have to give a long-term warranty. There's a lot of metal incompatibility in IBR roofing, where the screw might not be compatible with the roof sheeting itself or with the aluminium that's used on the mounting structure. Then that causes corrosion or rust to start, and then the system needs to be replaced or roof sheeting needs to be replaced. Secondly, the shape of the screw that we use is also very important so that it does not create metal shavings. The metal shavings also go onto the roof surface and create corrosion, but also as it's tearing into that, you can actually cut the roof sheeting and reduce the strength of the connection. So for those reasons, it's very important for us to use the correct screws on our systems. So this is designed to drill already, so you don't need to pre-drill into the roof sheeting. It's got a hardened drill tip there for that purpose. The rest of it is stainless steel so that it doesn't rust and that it doesn't cause galvanic corrosion with the aluminium. And it also has a gasket to prevent leaks and waterproof that. So that gasket is also quite useful if somebody drills the hole in the wrong place, then you can just put the screw in, leave it there, and it's sealed up that leak so that you don't have to worry about it. Important note in terms of drilling into thin sheet metal, you don't really need to torque it. You just drill to contact. So the torque setting people often ask about, it's less than 1 Newton meter for thin roof sheeting. So just to give you an idea, basically you place your rails down on the roof sheeting, you come and twist these parts into it. So I like to do that when the rail's already lying on the roof, then twist that part in, and then you come and just drill to contact. You don't have to torque it. You don't have to fasten it beyond contact. And then you place your PV modules on and you click your module clamps in to fasten it and replicate. So that would be our most popular IBR fastening system at the moment. Quite easy to use. I know a lot of people do like short rail systems, but I find especially if you're doing large projects or have a crew that's slightly inexperienced, they can struggle with short rail systems to orientate the parts. So if we look at a typical bill of materials or a typical use case on this single fix system, so here we've got about 1.8 meters in between the fixes. So you've got one there, one there, one there, and so on. So across 16 modules here, we've got 24 pieces of the single fix. Each one takes 2 screws, so that's 48 pieces. You've got your 70 millimeter rails that's running down the portrait clamping zones over here. your internal connectors to join the rails to each other. You'll note that we use the same one regardless of what rail we're using. Your end caps, likewise, one size fits all, and your mid and end clamps to hold the modules down. All right. It's not the only solution for IBR. We also have, you can use the same system on a short rail, but we prefer to use what we call the T-bridge in that scenario. So I'll give you an example of that. In terms of landscape flush mounting, very popular system over the last 15 years for us is called clamp fit. Great for your 54 cell modules as well that only require a smaller ventilation gap. I'll show you how that one looks. So if we have your IBR sheeting here and you want to mount flush mount in landscape, so the gasket is similar to the single fix, but it has a built-in mini rail that's running parallel to the drainage of the roof. So you place one at each clamping zone of the module. At the end of your line, you can do end clamps, and then you can share mini rails as you're running up your line. So also very popular system for us still. Lost count of how many megawatts of these went in this year. So with landscape mounting, it tends to follow a different line. You tend to run your lines down the roof rather than along the roof. So rather than doing a 1v16, I'm doing a 2h8 here. So 8 modules and 8 modules in landscape or horizontal. So we've got 36 clamp fits. Each one also uses 2 of the bimetal ETA screws. So that's 72 screws. And you've got your ends, and the sharing ones use the mid clamps. So very simple, very straightforward, fast and easy system to use. All right, if you want to use a short rail system in portrait, the T-bridge is a great way to do that. So basically we've taken that 70mm rail, just added a flange in the bottom with a gasket, and then we're fastening using the same screws to the top of the ridge. The size, there's several holes there to accommodate for all the different IBR sizes on the market. So that makes it easier to orientate where to place them. And likewise, you go to the quarter point zones and you can share the mini rails in between modules. Also a very cost effective system. And if you do find yourself getting into the edge and the corner zones of the rooftop, you can just place a third one there in the high wind zone areas, just to reinforce and support those modules. So again, you've got your fixing points on your T-bridges there, which would be 4 screws per T-bridge. So it does use a few more screws. So we've got 136 screws for 34 T-bridges, and then the rest works the same. On your higher wattage modules, if you want to run in landscape, this is a system I like to use. We can either do a small rail with a single fix, or you can just use T-bridges with a cross connector and then do a full railed system to make sure that those modules are properly supported, especially when you're getting into the very high wattage, very large square meterage modules. Might be good to support them correctly this way. And if you want to save on costs, you can also do that just by using a short rail and a cross connector. But full rail systems are the best in terms of honoring the module warranties and making sure that they're steadily supported. So pretty much the same system, except for that we are now just adding the cross connectors and we're adding rails onto it. So for the full rail landscape system, we're using 28 T-bridges, 112 screws, 8 rails. So it's 4 and 4. And the connectors on each side, we're using a few less because it's only rows of 8. end caps again to seal off the end of the rails, and mids and ends. Pretty straightforward. So the cross connector is the only major new part to be introduced on top of this rail so that that rail can run across it. Okay, looking at corrugated roof, we do have this corrugated clamp called Fix W Pro, which can also be used either as a mini rail if you want to mount on landscape on corrugated rooftops. You can either do the same as the T-bridge with 4 of the screws onto the sheeting, or if you're concerned about the sheeting integrity, you can also use a thicker bolt just to mount onto the wooden rafter that's underneath the corrugated roofing. So especially if you're using elevation profiles on this, corrugated roof sheeting tends to be relatively thin. It can be good to reinforce it a bit more. But for the most part, we're using 4 screws, which does spread the load quite a lot. So an example of that, on your corrugated profile, you got your 4 screws. You can place your module in landscape straight on it that way. So again, straightforward system, 36, 144 screws, and your mids and ends. Yeah, all right. So hanger bolts is a very old system, but a very reliable system of fixing directly to the substructure on IBR and corrugated roofing for the most part. I know in Europe they do it on fiber cement or asbestos as well. South Africa, I've yet to see a roof on one of those designs that can sustain additional weight for PV mounting, so it doesn't really happen here. But we have the stainless steel hanger bolts, which also supplied under a 25-year warranty, which can be mounted either to steel or wood substructure. Then you've got a part called a click top, which can attach a rail to this bolt. So this is mainly used in scenarios where the roof sheeting is not sufficient for the wind loads. All of these systems mentioned can have a tilt applied to them by using a system called Fixed Grid Pro or our Fixed Grid Pro rail. Basically what we have is a adjustable mini rail that clicks either into the Fixed Grid Pro rail or can attach with a cross connector to any of our other rails or mini rails. And then you've got a elevation profile, which is a click in pot. So if you add one of them, you tend to get, depending on where you're clamping, between, let's say, up to 5 degrees tilt. If you add 2 of them, you're going up to 10 degrees tilt. If you add 3 of them, usually on about 15 degrees tilt. And if you need to go beyond 15 degrees, then it's better to go to a more substantial structure, such as the A-frame, which is more expensive, but these can go up to 25-degree tilts. So as I mentioned in the beginning, it's important to note that the higher you're tilting the modules, the higher the forces on the roof. So it can increase the cost of the fixings, the amount of fixings that you need to use, but it's still usually possible. That just needs to be weighed against the additional benefit from the generation that is achieved. All right. Any questions so far on that? Okay. If there's no questions on the sheet metal roofs, then we can have a look at tile roof for residential. We have two types of roof hooks that are used to mount on tile roof structures. The one is called the Eco A45. That is an aluminium roof hook, which has an adjustable plate for orientation, and it can have a L bracket mounted on top of it if you want to also get additional height or variability over different tile profiles. And then it is significantly cheaper, even though it's just as strong as our highly adjustable universal roof hook, which is our mainstay product, and I think globally we've sold towards 40 million of these ones. But it's a great product because it's a stainless steel product that is adjustable in several areas. It's also got quite a strong base plate. So if you want to move where the roof hook originates from side to side, you can also do that. Many uses to that type of roof hook. But we see a lot of installers lately using just bent steel profiles to avoid using roof hooks, which is not ideal due to various reasons that I'll get into now. Okay, so these also use a M8 by 80 stainless steel wood screw. So that 80 millimeter screw is quite important to use, even though we only need 60 millimeters for most of our designs. I'll show you now why it's important to have an extra 20 millimeters. Okay, so probably the most common tiles that I encounter is the double Roman tile or the modern concrete tile, which in South Africa has replaced a lot of slate tile roof. The roof hooks that I showed now are suitable for both of them, and the most important thing to check is actually just the rafter thickness that is going to be used on the site. So when I mean the rafter thickness, we're talking about the gap basically between this rafter and the batten that runs, sorry, I meant the batten thickness, the rafter and the batten that runs across it over here. So you've got to be sure that the roof hook has sufficient height to go over the tile that you are using. And the reason for that is partly why I'm very anti people using bent steel instead of roof hooks on mounting on tile roof. You're transferring all of the pressure onto the tile. If that tile cracks, it's going to leak until it's replaced. If you replace the tile without replacing the roof hook, it's just going to crack again. You're going to have leaks again, and that customer is always going to call you to come back. So for installers, it's not always so much about repeat business from one customer, but it does waste a lot of time and money having to go back and deal with complaints from customers. The second thing is these adjustable plates here are quite important because often you open up a tile and this rafter is not running where you expected it to. So then you need to place your screw right on the edge there because there's a ridge on the tile over here. So this adjustable base plate at the bottom is also quite an important part of the system. All right, so over here what we've done is we've opened up some tiles. The first tile didn't have a rafter under it, the second one did. Orientated where to place that. At that stage, you should pre-drill with a 6 millimeter diameter bit so that you don't get too much expansion on your stressed rafter. It's 6 millimeters because the wood screw is going to be 8 millimeters. You can get away with 4 millimeters as well because there's quite a lot of threading on the screw itself. So once you've done that, you open another one and then you can start to measure out where your rails should be placed because these rails are going to run underneath your clamping zones. So it's very important to ensure that the spacing is correct. Otherwise, because there's a lot of variability in terms of module length. So it's actually good to consider what the length and overlap of the tiles are on the project before even deciding what module to use, because in certain cases, if you don't have the right spacing, you're either going to clamp outside the module manufacturer's approved zones, or you're going to end up using additional rails to mount in a different configuration. So over here we measure just from a side view. So there's the batten, this is the rafter running down, and the roof hook coming through there. So we just have to be sure that this spacing between these two is going to be between, in this case, 450 and 550. All right, so then the next problem that you encounter with tiles is when people place the tile back down, then the bottom ridge over here pushes against the roof hook itself. So what a lot of installers do is they just buy a flat piece of metal and slide it through there so that they don't have to flex out the tile over here. But that will, over time, crack this tile and result in leaks. So it's a short-term solution, and will probably cost you more money in the long run. So this is an example here on the double Roman, which is probably the most common tile in South Africa. So the installer is just flexing out this part of the ridge. You can see over there, it's about the width of the roof hook. If they're uncertain about what width to use, they can just place the roof hook there and mark it with a permanent marker, and then that cutting out section. I'm not an installer, but it takes me about 20 seconds to do it per tile. So if the workers are telling you that it's too difficult or it takes too long, I don't quite believe that story. It does not take that long, in my opinion. And it's an important part of ensuring that the system is actually going to run without leaks for a long time. All right, so you can see over here, we've got a fastened tile orientated to the left of the rafter because there's a ridge there on the double Roman. The overlap of the tile is short enough that it doesn't go in there. And now this little groove here will fit over that tile. So over there, they've done the pre-drilling into the rafter just to create a little bit of a hole for the wood screw. This guy's flexing out tiles. That guy's fastening roof hooks. So this installation here was 6 panels. No, it was 4 panels if I recall, and it took about 2 hours in total to do the site from start to finish. One note, when encountering battens that have additional height, shims can be used to create that. So I do see that it's not on every site. This site over here didn't use any shims, but sometimes the battens are higher or the type of tile has a slightly higher ridge. I've never seen more than 18 millimeters required, but we did a project up here in Bryanston recently where the batten was a bit higher. The installer found a timber merchant to cut pieces of wood like that for R2 each. So the cost of creating that 18 millimeter shim was not significant. Hopefully within the next few months, we should also have plastic shims that we will be supplying in the kit systems together with our roof hooks. But that's it. It's not used on every single site. So as and when needed, you can use wooden shims or plastic shims to raise it over that if required. Okay, so if we look, I think this was a single story example from Cape Town. So over here we've got 16 modules in portrait, which would use 48 roof hooks at a spacing of 800 between rafters. So each rafter was about 800 apart from each other. So that's 48 Eco 45s with 48 wood screws. The WrapFix Pro is this part that's on top. That is a easy connector, an adjustable connector as well for the rail to click into and fasten from the top. We like that because you don't always have a lot of space to fasten nuts and bolts from the bottom on rooftops. So we like a top fastening fixing between the mounting structure and the rail. Over here, the spans are not far, so the Pro 35 rail is sufficient. Same internal connector as always, regardless of the rail, and your mids and ends. So I do often find in Joburg and Pretoria that you can leave out some of these because the wind loadings are not as high. So we often see a staggered pattern, like a zigzag between rafters being used, which is absolutely fine as long as they, at the start and end of each row, so if they were doing 4, then you should have 1 roof hook there, 1 there, and then at the end, another there and there, regardless of the zigzag pattern. But if you do that, it can save you quite a lot of roof hooks. If it saves you roof hooks, that saves you time and money on site. So very applicable, also good to do. Okay, so flat rooftop sections is also a very, very big part of the market. I don't have time today. Well, I didn't think I had time. Maybe I can actually run through some design examples. It looks like we've got a bit of time. So there's two major variations in terms of flat roof systems, being a north-facing system, like this one we did at Sun City, or east-west systems where the modules are back-to-back. Which are often used on higher wind zone areas because the modules are protecting each other from the wind. Each one, we're happy to do each one. The price is similar in terms of the mounting structure, the amount of metal that we're using. Your generation curve is also different on north-facing systems versus your east-west. So at the end of the day, it's up to your project requirements what's going to make sense. But we've got products for it regardless. So the flat roof system is called Fixed Grid or Flat Grid Pro. If you have the north-facing system, most of the time, so on the smaller modules, 54 cell and down, you might be able to do short side clamping, which is good because you're saving a rail, you're sharing a rail down in the middle. But on larger modules, the rails need to run underneath the quarter point clamping zones to support those modules effectively. And I have only once seen a requirement to run a third rail on a flat roof in order to support that from the wind loadings, but it can happen. So the same parts are used regardless of whether you're doing north facing or east west. It's just a matter of placing the modules back to back. So some important parts of the system, the flat rail that we use is designed that way so that you can ballast either along it or across it or both. We have a special rubber mat that has a foil side to not cause plasticizer migration from the waterproof linings on concrete rooftops. That rubber then absorbs the movement as well of the aluminium expanding and contracting or the wind lifting and dropping the modules. So very important that there's one of those rubber mats at least under each ballasting point or elevation point. And then again, it's the same elevation profiles that we would use on pitched roof called the fixed grid module support or the elevation pro. So same story. If you want 5 degrees, it's typically 1, 10 degrees, usually 2, 15 degrees, usually 3. But the clamping zones can affect what your effective tilt is. So it'll be different from module to module. So you can also do the same system in a flat system without tilting them. This is used also quite a lot in highly developed CBD areas where you can get a lot of wind loads over the parapet of the wall. So sometimes tilting isn't ideal, but I've also seen these being used in beach houses with flat roofs, flat concrete roofs, or if the roof has a bit of a tilt. I saw there was an interesting one done on an ice rink in Germany recently where it was actually a sheet metal roof, but they ballasted it because they didn't want to penetrate that surface. So if the roof can sustain the additional weight, you can also use these flat grid systems on other roof types other than concrete. I think it's even been done in some cases on parking lots and other sites as well. So it's quite versatile. Okay, so I can maybe run through some design examples of the different products. First, go back to the chat and just have a look if there's any questions. But in terms of accessories, there are some important accessories. I think the biggest seller on our accessories is this saddle clamp, which we designed together with Dan for lightning protection, finials, bonding, earthing, copper or aluminium cables. And what's good about it, it's a bit more expensive than just using lugs, but it's designed to be relatively neutral for the metals that are going to be used. And that means you don't have to come and replace it due to corrosion regularly. So more of a long-term solution in terms of a bonding clamp. And it's versatile. as it has a smaller side for thinner cables and a larger side for thicker cables. So that can slot directly into our rail or into the mini rails of any of the systems that I've shown, so that you can bond different arrays. If you do have inquiries for ground mount projects bigger than 200 kilowatt peak, where it's possible to do geotechnical investigations, we have the FS Uno and Duo systems, which we've done, I think, over 35 gigawatts worth of these systems globally, where you pile driving posts into the earth. That's a very, very fast process to do with a ramming machine. In some cases, getting up to 200 posts or foundations placed in a day. So I think we had a project in the Cape recently where we did a megawatt in a week in terms of the foundation installation. But yeah, it's definitely something that we can talk about. Quite a lot of options in terms of the materials, which we will design based on the corrosion zone of the area, and highly price competitive as well. So if you've got bigger projects, feel free to talk to the IBC team. We'll see how we can support to realize that. Carports we do not do on a small scale. We do have 4 types of carports. We might in future have a small scale carport kit-based system, but it's not available just yet. But as well, we start looking at carports from, let's call it 250 kilowatt peak and up. So in terms of the designs of carports, for me, this is the best one. It's called Sunride because you've got a lot of usable space. You've got very strong steel posts in case of collision, underground, very strong steel reinforced concrete foundations. So because there's a lot of moving vehicles, delivery trucks, and if a collision does happen, you don't want PV modules that are live to come down, as it's also an electrical and fire hazard. So there's very, very cheap carports on the market. That's not the game that we are into, but we're happy to support with good quality carports, strong fit for purpose carports. But unfortunately, we are not geared to do it on a small scale at this stage. I saw there was a question about a slide to be shared. I missed it at the time that it happened. If you could maybe just post in the chat which slide it was.
Zander, I think they're referring to the whole presentation. I'm not sure if you guys share presentations.
Yeah, not a problem.
Okay, cool. I will then
additional data.
Thank you. I will then upload the presentation and the links you mentioned along with the recording on the website later today. Latest.
All right, great. I'd like to put it, if there's any questions or any of the types of installations that we could go into further detail on, I can also do a demonstration in terms of the software that is available just to put some of that data into practical use. All right, so this is our app, which we're still using at least for this quarter, called Calc 3. So basically, you would start at this page where you would put in your customer and contact person. The next step would be to find a location. So we can choose a site. Let's have a look. What do we got? This looks like a flat concrete roof. Okay, so as I mentioned earlier, in terms of terrain category, it looks to me like an urban area. Most of the buildings are together. If I look at the shadows and the profile here, it looks like most of the buildings are less than 15 meters. Most of the time, best to work on category C, and for open areas category B. Like I said, unless you're next to a lake or completely open land in next to the Orange River or somewhere up there. So I'm going to take it as terrain category C. It's a flat, relatively flat terrain. It's not KZN's Valley of the Thousand Hills. The corrosion will be built in based on the map. So in Joburg, C3, moderate, still means relatively high corrosion. Unfortunately, the pollution up here is quite severe. So we do have some corrosion in Joburg. And then, as I mentioned earlier, those SANS codes are built in based on these assumptions. Now it will create the wind pressures. So then I can say either free data input if I just want to type in my assumptions, or I can select my site area. I think I might have a lot of apps open. All right, so I've chosen my spot now, the area of interest. It'll pop up a window now so that I can decide what it is. So it's not a gable roof, it's not a double slope, it's not a monoslope. It looks like a flat concrete roof to me. Based on the area I selected, it is now put in some measurements. I can adjust that manually if I disagree with it. I haven't done a site inspection, but I can see there is a bit of a parapet on the ridge over here. So that parapet is typically 0.5 meters high on buildings. And we may be sitting at 9 meters here, I would guess. How many stories does that look like? And then the roof pitch on flat concrete roofs is usually not more than 2 degrees. So let's go with 1 degree. Okay, so that's now configured. Then we go next onto the configuration tab. So we want to select what system. We're doing a flat concrete, we're doing fixed grid pro or flat grid pro. So let's go tilt structure for this one. All right, and then it's got my site over here. Okay, so first thing, what module size we're using, small modules or big modules. So let's go with big modules. That's mostly what I see on the market at the moment. So it's plus. The 100 will mean east-west system. So most east-west systems I see is you want to be more than 10 degree tilt. So let's go at about 13.5. And then we can go, do we want to support the entire rail or just under the supports? I'll just say under the supports. We're going to use rails that are maybe 6 meters long. I haven't decided how many I'm going to use yet, so I can come back to that. And then what size bricks are we using? We're using big ones. Let's see what the loading's like first. Okay, so right click, new module array, or I can say new non-usable area. So let's start with a non-usable area. We can't mount over here. So I'm going to block that out. Do another one over here. Actually, maybe this whole area, it looks non-usable. So what's nice about our new creator app is that it would do all of that for me. Okay, so blocked out those, and then we can say new array. Okay, so there's my modules. Maybe I can zoom in a bit. It's a little bit far. Okay, so if we get close to them, you can probably see you've got one module there facing west and one there facing east, one there, and so on. So in South Africa, we have a maintenance walkway requirement of minimum 300. If you do want a bigger one, then we can just do manual input and make it 450, for example. If you do want to separate the blocks, we can also do that at that block distance over there. So the blocks would be these sections, but I think does it make sense at the moment? I think we might need a walkway gap there and a walkway gap there. And this feels a little bit like it's gone over the edge to me. So let's move this up to here. All right. So in terms of these systems, we won't have a lot of options for base beams. It's going to be the same. If we do a pitched roof example as well, then it will have a lot more options there. So you'll see over here, we've got different colors, which will, if we put on ballasted zones, it'll tell you that all of the blue areas need 28 kilograms basically, or yeah, there's a bit of a downhill force there. So let's call it 31 kilograms for the blue areas, 5 kilogram ballast for the red areas. So it has now mapped it based on the shape and extensive wind tunnel testing that we've done in Germany to create a ballasting plan for you. And if we want to see what that looks like, we can go onto the schema view. Just tell me if you can see that a different screen pop up now. I don't know, Zane, maybe you can tell me. It should be showing. It should be showing a side view of the modules with the ballast.
No, it's still showing the.
Okay, let me share this one quick. Okay, can you see that?
There we go.
Okay, so if we look, the maximum length on the site now is 5 rows. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 modules. If we go zoom into one group of 2, then we can look at the individual components here. So first we've got our rubber mat underneath the support. Then we've got our rail that runs down there. So this is the way that I do want to distribute the flat roof systems going forward, is basically just to find one rail length that works for the common module sizes that you guys stock. And then pretty simple just to replicate this, because the only thing that's going to change is how much ballast is required per module. All of the rest of the components will just be a carbon copy of each one. So in this case, if we change between different stone weights, we will see how we are going to ballast here. So it's not a very intensive site. It's in Joburg. So if we use 7 kilogram blocks, then this is how we would pack them under the modules onto the flat rails. And then that just repeats. So if you do want them to be joined, then we just need an extra half a meter of rail. But in terms of the statics and forces, these work in 2 module systems. So each 2 module group should be self-sustainable. All right, so we've pretty much got what we want on this one now. We could, if we wanted to break up the blocks, we could do that there by adding maybe another 450 walkway in between, but we would lose some modules that way. Let's say in this case it's not necessary and just leave it as is. Then if you go to calculation, it creates your bill of materials. On the next version, the pricing will actually work for the wholesalers, but at this stage, it's gibberish. So the weights and the quantities of each product is there. But if you want to then print that and give it to your customer so that, or your installer, so that they know what modules to place where and what weights to place where, you can just go to design report. Can we see the design report? Okay, so if the design report is visible, let me come down to the plan. Okay, so each one of these thick lines over here is now rails. So in terms of ballasting, as I indicated, you can either pack, because it's a flat rail, you can either pack lintels or bricks that way, or you can pack them across the rails that way. I would say the majority of the sites that I've seen, especially larger CNI sites, people tend to pack concrete lintels across that way for the weight. It seems to be the cheapest option and relatively easy to handle, but the rails can support either system. Maybe I can find a picture of that for you quickly. In terms of the screenshot, you can do a free data input. I've actually never tried myself to do a screenshot of it. I'll just check with my technician that normally does those designs. But if you have a drawing of the building plan, what you can do is just basically go. If I just go back to this section here, if I go back to project and roof areas, then you can do free data input and just put in your own values. It doesn't have to have a background picture on. And it will just look like that. So then you can just make sure that these dimensions of the unusable areas, you can just input them. If your engineer drawing says that that's 14 meters across there, then you can just edit these to 21. And it should give you all of your measurements if you select each individual object. All right. So I think that's relatively straightforward on flat roof. If we change it to north facing, it'll change the design pretty quickly. Now all of the modules are facing north. There is, okay, so the shading is quite important. There's an automatic calculation in here that was done by Erfurt and partners based on the latitude and longitude of the site, just to come up with the potential shading. So you can manually change that, but here in this case, it's just saying 1.4 meters. So 1.4 meters would be 1.4 meters from the start of the first module to the start of the second module. So basically your 1.4 would start there and would end there. And then the next 1.4 starts there and ends there. But yeah, as you get more comfortable with the software, what's great about it is you can generate your bill of materials, send that through to IBC for pricing, and have the project quoted very, very quickly in that manner. All right, so let's have a look at just an overview in terms of flat roof. We can have a look at a different roof type perhaps. So should we change our location here? And we can just delete previous one. Strange installation. So we can see this is a gable roof. So even though I'm going to only use the one side of it, I'm going to leave it on gable roof. What happened here? It's on free data input. Oops, a little bit skewed, but all right. Okay, so this looks like maybe double story, not a tile roof. It looks more like a sheet metal roof to me. Make it 25 by 60. So the clip lock roof types tend to have a very low slope, anywhere from 3 degrees upwards, which is part of their selling point because you're getting more coverage, more under roof area for less metal. So I'm going to leave it on, when I don't know, I tend to leave it on 5. So the figures that I had there earlier, is important to know the different roofing that you're dealing with. So clip lock 700 has a seam distance of 233 in between, 233 millimeters in between seams, but it's different between different roofing types. So it's nice to have a reference sheet on what the drawings or the spans are, but when in doubt, it's all on Google. You can just have a look at it on the manufacturer's site. They tend to have steel purlins. So we change that. Maybe 3 millimeter steel, but not, since we're not going to mount to the substructure without hanger bolts, it's not that important. So first important step now, choose our mounting system. It's a pitched roof and we're using Proline. Next important step, we're not mounting to the substructure, we're mounting to the roof covering. So we have to select that. Next, what is our solar module? So we can take Longi 590 to 672. And then we want to say, okay, it does look like these might be polycarbonates that they might want to retain open. So maybe we should make that a non-usable area. Something like that. And then we can put, actually just want to know, so where are the edge and corner zones? Don't want to mount there. So can put an array there. Put one over here. Would actually just drag it over. It won't mount on the disrupted areas. All right, so now we've got some arrays. Next, we have to choose a fastening. So we probably have a seam clamp 551/4. Well, I'm not seeing it, but we can use this one. And because it's a high profile seam clamp, you're getting enough clearance already. You don't need to use a Pro 70 rail, Pro 35. It's also telling me that in terms of the spans that I've selected, that the rail is only 10% utilized. So, you know, it's pretty comfortable, not being stressed too much. So let's go to 140 spans. And we can always come and check if there's a challenge. Edge and corner zones are now a bit risky, so we might have to triple clamp there. But the center zones still very, very happy. Rail's very happy. Module clamps, no problems. Okay, so I can remove that. Okay, so now we can have a look at the parameters for each module, and we can edit each array individually as we want to. If we wanted to put that one in the edge and corner zone, we might need to then change the span to use more fixings. So all of that's fine. 1.4, 1.4. If we did want to put this one there or that one there, then you might, let's just actually put a couple of them there. So we can go there and we say separate module array here. Give a offset, drag that there, and put an additional beam across the center to support those modules. So if I zoom in there now, then we should have 3 rails down there, over there. So those modules are now happy, even though they're in a non-advised area. These ones are fine. And then likewise, your calculation will give you your bill of materials for the parts. But typically your BOM is going to be, as I indicated there in my slides, using those parts from this section. Like so. So one of the other things that I haven't covered that I do like to talk about as well is rail lengths. So you'll see over here I've got 4.7 meter rails. Now, I tend to like using 4.7s whenever there's multiples of 4. So if you've got 4 modules in portrait, fits nicely on 4.7 rails. Likewise, if you've got 8, 12, or 16, it will also work. If this was 3, then you would have more efficient use of rail on a 3.5 rail. And if it was multiples of 5, then you would use a 5.9 or 5.8 rail. So that rail length is relatively important to me in terms of our stocking of parts. So just good to take into account there. And I think that IBC's stocking of the rails also follows that. So just useful to take into account. I know that not every installer likes to use different rail lengths on a site, but if you don't want to cut rails, then it's pretty simple to just think of 3 is 3.5, 4 is 4.7, and 5 is 5.9.
So then there was another question in the chat about what is your take on the wind tunnel button?
So the wind tunnel button only works when the roof pitch is relatively low. It's based on quite a lot of modeling that we've done. And I do think it's fairly accurate, but where I would use it with caution is to determine what the maximum pressure on the module is. I'm pretty comfortable with it in terms of our mounting structure. But if you want to see in terms of is that acceptable within the module warranty, then I would check that pressure without the wind tunnel function on. So it does have a use, and I do think it gives you pretty accurate values for mounting structure, but for the module, check that without the wind tunnel function. All right, so with that example over there, we've got our bill of materials here. Likewise, you can print your design report, and that design report is a very important part of project handover on CNI projects as well, to ensure that the insurance will cover it in the event of a wind event that the site has been calculated according to Science 10160-3. So I do recommend going through the process. We are here to assist if there's any challenges in terms of the design or software or something that's not making sense to you. But overall, I think it's relatively easy to use, and we have provided these examples of 16 modules array and so on to make it easy to use, to make it easy to think with it. I think if you guys do have any, everybody uses different combinations of modules and inverters, so it's great to have feedback to hear, you know, how many modules are you stringing together, how many modules are you stringing together. Then it can also help us to configure solutions based on, should we be working on 4, 8, 12, 16, or should it be 5, 10, 15, etc. I see there's a question with relating to the lintels. Let me see if I can find a picture for you quickly. We do use lintels on a lot of sites. Maybe it will be quicker if I just share an image. How do I get it from my phone now? I think I've got one on my email. While I'm busy looking for the lintel and blocks pictures, any other matters? Did I answer the question on the wind tunnel function? Is there any other query on that? Not really a great picture. I can't seem to share pictures there either. Let me just find a different one. Okay, I think I found a picture that illustrates the lintel story. Okay, so if we're looking sideways here down an east-west array, you see here's the flat rail with the rubber mat underneath it, and we've got concrete lintels now laid across the flat rails. So that's what I was saying. You've got quite a long length over here, so you can either lay bricks or lintels down the flat rail that way or across it. The option's yours depending on what makes sense in terms of the ballast that is available on the site or nearby. And the weight that's required for that specific array as per the design report. So if we're looking along down the rails, which should now be under the quarter point clamping zone, you can see here lintels placed across there for ballasting, which is incomplete going down there, but relatively complete on the right-hand side here. So we don't supply the lintels because they are freely available from concrete or hardware stores around the country, and there's projects all over the country. So it wouldn't make sense to us to stock the lintels and supply them, because we would just be adding transport cost onto that. But what we do provide in the design report is the calculation as to how much is. Okay, then I see your answer there. So no, anything can really be used as long as it's effectively transferring that weight across the rail or both rails, and that minimum requirement in terms of the uplift is matched in terms of the ballast. So we are not specific in terms of what is required. There's many ways to ballast these. I think it's not unique to us, but we should be compatible with just about any ballast system. So if you have a specific request for a specific type of ballast that doesn't seem like it'll work, just let us know.
Okay, I think that was, I think we've reached the end. It was a very informative session, I would say. Thank you for going into the details, and also thanks to everyone for engaging and asking questions. That's the only way we know what you guys want to learn about and what we need to cover. So yeah, thank you so much, Vander. Really great session, and yeah, I think everyone who watches the recording back later is also going to enjoy learning all the information you provided. Yeah, if there's any more questions, please feel free to send them through to me, and I'll communicate with Sander. And like I said, the presentation as well as the recording will be available a bit later. I also want to encourage everyone, if there's anything else you would like to learn more about, please let me know and I'll arrange a webinar on whatever topic you guys request. So yeah, thank you so much, Sander. Thank you for joining.
Thanks to everybody. Thanks for setting it up and hosting us, Zane. Always a pleasure.
Thanks.
Thank you.